Today, let me explain how to write quadratic equation in Python. Before that, we can see few applications where quadratic equation has used. Mostly in sports, cricket, football and basketball, quadratic equations are used to describe and predict the path of the moving ball. Apart from this, to determine the proper curvature for tunnels, the shape of dams or the curve of a bridge we can calculate by using of quadratic equation. These are all the applications of quadratic equation. Let me explain how to write Python code for this quadratic equation. Initially, I imported the math package. This package we have to import to find the square root of delta. Then we have to get the coefficients of quadratic equation from the user, that is a, b and c. For that I have included that a is equal to input enter a, that is we can get the coefficient from the user. Then we can check the condition. If the coefficient a is, we have to compare, it is a 0. When it is 0, we have to print value of a should not be 0. Then the problem execution will be terminated. Else we have to check three conditions here. First we have to calculate if a, the coefficient is not 0, delta is equal to b square minus 4a into c. Once we calculated the delta, we have to check if it is greater than 0. For that we have used if else condition here. If delta is greater than 0, it is the statement has ended by colon. In Python we have to give colon after in if condition, elif then else. Then root has been calculated. Root 1 is equal to minus b plus math dot square root of delta. The quadratic equation is minus b plus or minus square root of minus b square minus 4a into c divided by 2 into a. To use the square root function only we have imported the math package. Then root 1 and root 2 has calculated by using of square root function. Then we can print that when the delta is greater than 0, that the roots are real and unequal. If delta is 0, that is b square minus 4a into c, then root 1 has been calculated by using a formula minus b divided by 2 into a. Then we can print roots are real and equal. Then if the third condition is also there, delta is it can be greater than 0 or equal to 0 or it will be less than 0. When the data is less than 0, the roots are complex and imaginary. To run this function, go to run, just give run module or F5. Then we can enter the coefficients. I am giving a value 5, then b value 6 and c value 4. So the result is roots are complex and imaginary because the delta value is less than 0. Thank you.